We are live now. You are live. Hey. Yes. So it's working. No, 0. Let us see some more timeline. It's 0. It's 0, 0, 0. Yes, it's working. It's working. 0. Then what? Next what? Yes, I'm coming. I am live on the YouTube. Now you can go there. Okay. So Zoom share. No, it's not sharing over. Yes. Right. Oh, who is this annotation wala? Itna annotation किसने किया इसके ऊपर? Who is this person who is doing annotation? I have to stop share the screen again. Now I have to put the annotations. Where is the annotation button? Oh my god, you people, what you don't do annotations? Here the option is not going for the annotations now. What is this shit? Hold on. I have to go in the settings and now. Okay, now nobody will do annotations. Please. Okay. I'm starting it. I've launched the poll. Students, please participate in the poll fast. And I request all of you, don't do annotations. I'm not here getting the option to close annotations. Okay. Don't do annotations here, please. Request to all of you. Meanwhile, participate. Meanwhile, participate in this poll so I can get to know, yes, I'm audible or not. And is the screen properly visible to you or not? Is the screen properly, students, visible to you or not? These things are so much important to be confirmed before starting the class. So I can share the result. Majority of the students are saying, yes, it's visible and the thing is audible. Fine. Yes. Yes. Yes and yes. So students, without wasting time, let us start the class. Everyone is ready? Gives a hand. Give what we say. Gives what we say. It's thumbs up. Let us start it. Let us start it, students. Let us start it, students. Let us start it, students. Hussein says yes. So students, we'll go to the electric field fast. ठीक है? अगर time मिला तो we'll start the electric potential also. ठीक है? Let us move. So let us start with the electric field. If we are left with some time, we'll complete electric potential also. We'll do some closeness of this video. Okay, students. So let us start it. Okay. Here we go. So the things which we'll be revising it fast in just 5 to 10 minutes. The thing which we'll be revising in 5 to 10 minutes are these things. Okay, some of the students have texted me something. Good evening, Mahesh. Yeah, students, there are a lot of names. I can't, tell all the names fast and fast. So we'll start the class now without wasting time. Okay. So first we'll see electric field due to a point charge. That what is the electric field? If I show you here, see that what is basically, students, the electric field due to a point charge. Electric field due to a point. This we'll see that if a charge Q is placed like this, Yeah. Trupti, JNV Devangiri says this is this much. Yeah, that's fine. Suppose there is a charge q at a r distance. If you need to find the electric field, it is k q by r square, like this it is. It is kq by r square. Okay. Electric field due to multiple charges. Suppose you're having multiple charges q1, q2, q3, q4, q5. These are the multiple charges, है ना? And if you need to find at this point, say P, this is at R1 distance, this is at R2 distance, this is at R3 distance, this is at R4 distance, this is at R5 distance. If you need to find at this point electric field, you will do the vector sum. And then at the end, we'll see the electric field lines, which is somewhat new, maybe to majority of the students here. Okay, let us proceed. Students, let us consider a charge Q in a vacuum. Suppose this is a charge Q and this is placed in vacuum. I hope you all of you know what is vacuum or vacuum. Hai. I hope that all of you know what is this vacuum or vacuum. Now we place another point charge, students. Now we place another point charge Q at a point P. So I am placing here a point charge plus Q at this point P. You can see with your eyes. Hai. So this is at, we'll say it is at R distance. Hai. So we need to find a force here. What force I will say? We know this thing. Suppose we are having the two charges Q1 and Q2 like this. Okay. And if they are placed at R distance, if you're having two charges Q1 and Q2, and if they are placed at R distances, and the nature of the both of the charges are same, I'm saying if the nature matlab, this is also positive charge, this is also positive charge. So इस पे जो force होगा, this will be equals to K Q1 Q2 upon R square. इस पे भी because this both the charges are similar in nature, इस पे भी जो force होगा, ये होगा K Q1 Q2 upon R square. These are the forces here like this. ठीक है? So similarly here also the force which will this small plus Q charge will feel is equals to what is the force? Can anybody reply here? What do you think? What will be the force? The force will be K Q by R square like this. This will be the force. But our mission is to find what? The electric field. Yes. Very good, Tripti. Our mission here is to find the electric field. So electric field will be this column force divided by charge, or I'll say electric field is defined as per magnitude. Although it's vector quantity because it is equal to force by charge. Force is a vector quantity. But in the magnitude sense, I'll say like this. In the magnitude sense, I'll say like this, that force per unit charge, that is K Q by R square per Q. This will be equals to KQ by R square. So electric field here is equals to KQ by R square. This is the answer, students. Okay. So now you can say, if somebody asks from you what is electric field at a point, you will say it is independent of other charge, or it is independent of test charge. Remember this, that it is what? It is independent of test charge. Okay. Next. Q. Suppose we are having a Q source charge. If I'm bringing a Q test charge, this is a small Q test charge. Test charge is what? Test charge, you can see unit positive charge. You can consider like this, a unit positive charge. What does it mean? It means the charge which is having the positive nature, okay, and 1 unit charge. If it is at R distance, here the electric field will be, I will not write this value, I will write KQ by R square. If I am bringing this Q test charge nearby somewhat, say at R1 distance, same Q test charge, still here the electric field at this point will be KQ, which is this capital Q by R1 square. Okay. So we can say electric field is independent of other charge. It is dependent upon what? Just the source charge. So for the source charge only, the electric field is defined. Students reply in the chat box. Is it clear? So for the source charge only, the electric field is defined. Is it clear, students? Reply in the chat box. Few more points, students. Abhishek says clear. Very good, Abhishek. Few more points, students. Suppose you are having a source charge. This is what? This is something which is a source charge. Okay, Jenny Kadagu. Suppose this is a source charge, capital Q. If at a distance, say, equals to R distance at a point P, okay, if I need to find the electric field, its direction will be, if the source charge is positive, so we'll say electric field will be always and always, we'll say electric field will be always and always be directed radially outwards from the charge. Remember this always. If this is a source charge, I'm repeating it again. If this is a source charge, so electric field will be always and always directed away, okay, from the source charge, if it is positive. Okay. Now if the source charge is negative, suppose this source charge is negative, so at this point electric field का magnitude तो same ही रहेगा, kq by r square, if this distance of the point P is r, but the direction will be towards this negative charge. Electric field is equals to kq by r square, magnitude is always right, but the direction of the electric field will be negative. So we can say like this, if, I'm writing here a few points, okay, if source charge is positive, electric field direction will be away from the source charge. If source charge is negative, electric field direction will be towards the source charge. The source charge is positive, electric field will be away from the source charge. If the source charge is negative, electric field direction will be towards the source charge. Okay. These questions we have already solved. Will not solve these questions, but we'll directly switch to the next question, the next theory topic. Okay. So students, I hope it's visible on your screens. I have switched to the next theory topic again for the revision. That is electric field due to multiple charges. This is what this is, electric field due to multiple charges. Okay. Suppose students, let me show you. Suppose in a space there are different charges. Say Q1 charge, say Q2 charge, say Q3 charge, or say Q4 charge. Okay. Suppose in a space we are having 4 charges, Q1, Q2, Q3, Q4. And yeah, very good, Tripti. Tripti says, if we need to find the net electric field, it is a vector sum of all the Q charges at a point. Yes, very right. Suppose we need to find the electric field at this point due to all the charges. This is a P point I'm talking about. Suppose we need to find the electric field at P point due to all of these charges, Q1, Q2, Q3, Q4. So first of all, we'll mark the distances of the point P where we need to find electric field from the respective charges. So from Q1, the distance is R1. From Q2, the distance is R2. From Q3, the distance is R3. From Q4, the distance is R4. So this is these are the net electric field vectors you can see. This is E1, this is E2, this is E3, this is E4, like this. So we can say net electric field is equals to E1 plus E2 plus E3 plus E4, like this. Okay. This is k q1 upon r1 square r1 cap. This is k q2 upon r2 square r2 cap. This is k q3 upon r3 square r3 cap. This is k q4 upon r4 square r4 cap. This will give you the net electric field intensity. Remember it always. This will give you what? This will give you net electric field vector intensity. Okay? I hope it is clear. Students, if this thing is clear, please reply in the chat box. Students, if these things are clear to you, please reply in the chat box fast. Reply karo chat box fast. Jaldi karo. Jaldi karo. Is it fine or good? Abhishek says clear. Same Abhishek. My name is also Abhishek only. We both are same. We both are friends. Swati says okay, fine. Let us move next. Again, a challenge came. We'll not solve this question. It's a boring one. Let us start some new thing. Yeah, now it's the time to start this. So students, for JNP Mysuru students also, it's a new thing now, okay? I'll say for JNP Mysuru students also, it is what? It's a new thing now. All when it's loading. It's loading. It's loading. Preeti says yes. So now we'll understand electric field lines, okay? So now we'll talk about what? We'll talk about the electric field lines. It got somewhat hanged in between. Now it's fine. Okay, so now you can see we'll study this topic, that is electric field lines, okay? And it is not moving next. Suppose in a space, students, suppose in a space, if we are having these many number of charges, I hope you're able to see the screen properly. Hai? Suppose in a space, we're having these many number of charges. Okay, Trupti says the electric field lines emerge out of positive charge. Okay, so that's right. But whatever, suppose in a space we are having these many number of charges. Q1 charge. Yeah, very good. Q1 charge, Q2 charge, Q3, Q4, Q5. This is a point A. Hai? Suppose the electric field line is going like this, or the electric field vector is going like this. So what you can comment on this? And this is a B point. This electric field vector is going like this. If I say okay, this is a C point. This electric field vector is going like this. So joining all these points will give me something which is known as electric field lines. Okay. So we say like this: electric field line is a curve drawn in such a way that tangent to it at each point is in the direction of the net field at that point. Very simple, students. For you people, what you have to keep in your minds, in your brains, is this thing: that suppose you're having a Q1 charge. Suppose, students, we are having what? Suppose we are having a Q1 charge. Suppose you're having a Q1 charge. So electric field lines originate from a Q1 positive charge. Remember it always. Electric field line originate from a positive Q1 charge, and it originates from the positive Q1 charge and it terminates at Q2 negative charge. It originates from a Q1 positive charge and terminates at a Q2 negative charge. Remember this always. I'm writing, I'll show you curve here. Just hold on. First of all, let us discuss some properties of the electric field lines due to charges. Okay. So first of all, what we're going to do is this: we'll discuss some properties of electric field line due to the charges. Just focus here. Okay. See students, this is very easy chapter. No need to stop in between a lot. Suppose you're having a positive small q1 charge and there is some big magnitude capital Q charge there. Okay. So what usually happens is this. If we join both of these charges, or if we take this small plus q1 charge and capital Q charge, okay, as a what? As a system. Okay. So we'll say like this. Of course, since this both the charges are having what nature? These both the charges are having what nature, students? This is a positive nature charge. This is also a positive nature charge. So repulsion force they will feel F1 F1, है ना? And magnitude here we know it is equals to K Q1 Q, and if this distance is R distance, this will be R square. Everyone knows this. Suppose here is Q2 charge, इस पे F2 force होगा, similar magnitude we can write, okay? So properties. Remember always. So from the previous slide, we can comment this thing that when there was a source charge, so due to this source charge or इस source charge के कारण, due to this source charge, plus Q1 charge was feeling a force F1 like this, and this Q2 pay force will be this. So we can say we can comment from this that from a positive charge, Coulomb force is always away from the charge. And vice versa. Remember always, and vice versa. What do you mean by vice versa? Hold on, let me see the time. What is this? And vice versa. It means that for a negative charge, Coulomb force direction will be towards the negative charge. If it be positive hai, so it will be away from it. If this would happen like negative, it will be towards it. So we know this thing. Electric field vector is Coulomb force vector by a charge magnitude. So we can say direction of electric field is equivalent to the direction of Coulomb force. Remember this always. That is, direction of the electric field is same as the direction of the Coulomb force. So we'll say we can directly extract from this thing that for a positive charge, if a Coulomb force is away from the charge, electric field direction will be also away from the charge. And for a negative charge, if the force cap direction is towards the charge, electric field cap will be also towards the charge. Okay, I hope it's clear. I hope students it's clear. Okay, so now we can conclude at the last some properties that field lines basically what? Precisely if I say electric field lines, always start from a positive charge. Okay, and next if you see if there is some negative charge, these lines will terminate at negative charge. We can always see like this. So field lines start from the positive charge and end, it will be like this towards. And then end at negative charges. Okay, if there is a single charge, they will start and end at infinity. So remember always one thing. Yeah, if in a system there are two charges, say positive charge and negative charge. I repeat it again. If in a system there are two charges, say positive charge and negative charge, then electric field line will always originate from positive charge and end at negative charge. Okay? But suppose if we see in space just only one positive charge, so we'll assume like this, that negative charge is at infinity, such that the positive, from the positive source charge, electric field lines originate and end at infinity. So that is the meaning of the second line, which says If there is a single charge, they may start or end at infinity. What may start? They matlab kya? What they? They matlab electric field lines may start from source charge positive and end at infinity, because there is no such negative charge nearby to it. So we'll assume negative charge at to be infinite, at infinite. Okay, students, I hope it's clear. Students, I hope this thing is clear. Now next property is this. Next is this property, students. This property, this property, this property. That two field lines can never cross each other. Remember this thing. Preeti says clear. Good. Next property is this, students. That two field lines can never cross each other. What does it mean? Yeah, very good. It means like this, students. One of the students have given the answer. Tripti have given the answer. Suppose this is, yeah. Suppose this blue color is some blue charge. This green color is some green charge. And electric field lines are passing from these charges and they cut each other at a point which is this red point. Okay. So we'll say if I draw tangent to it, this will give me the direction of the electric field. If I draw tangent to green line, this will give me the electric field due to first charge. If I draw tangent to the second charge, second field lines, this will give me the direction of electric field intensity vector. So at one point, we can't say there are two directions of electric field. Okay, so this doesn't exist. Is it clear? Yes or no, students? Because at a single point, you can't have two directions. If someone asks from you in which direction you will go, you will say no, I'll go in east direction, west direction, north direction, south direction, east, west, northwest, like this. You will not say like this. I'll go in east also and I'll go in west also. I'll go in east also and I'll simultaneously go in south also. This can't happen. And you can go in between the directions, but you can't go in two directions which are well differentiated together. You can't go in those two directions. So that's why we'll say here, using the same analogy, we'll say like this, that electric field, two field lines can never cross each other. If they cross, it will be having two directions of electric fields. Remember it always. If they cross each other, the field at a point of intersection will not have a unique direction. It will be having two different directions. It will be having two different directions. Okay. I hope students it's clear. I hope students it's clear. Next, some more properties of the electric field lines. Let us see. So these are the properties. The magnitude of field is represented by the density of field lines. Always remember this. So wherever you find the electric field lines are closer to each other, you will say that here the magnitude of the electric field intensity is greater. If you find somewhere the electric field lines are well away from each other, you will say in these regions, electric field intensity is less. Note it down, students, fast. I hope you got it. If you find, see, what's the reason behind this? That if you are finding in a particular region more number of well concentrated, closely compact electric field lines, you say electric field is more. Why? Because this can only happen when there are a lot of system of charges in a region. If there are a lot of number of system of charges and the nature is same, there are a lot of number of electric field lines. But if the charges are very far away, electric field lines will be less, and consecutively, we'll say magnitude of electric field intensity at a point, but due to multiple charges, will be less. Okay? I hope it's clear. If it's clear, please note it down. And if you've noted, reply in the chat box that if it's clear. I hope students it's clear to all of you. Usab says it's clear. Very good, students. Okay. Region of weak field. Suppose students you're having a source charge. This is a source charge. And the electric field lines are passing from the source charge like this. You get same is the explanation. That in this region, and this region will say, in this region we'll say electric field intensity is greater, and in this region we'll say electric field intensity is less. Okay, in the below region we'll say electric field intensity is greater, and in the above region we'll say electric field intensity is less. I hope it's clear to you, all of you. I hope students this thing is clear to you. I hope students this thing is clear to you. Clear हो गया ना? Yes or no? बोलो yes. You can see Shinchan package at background. Pyara, pyara. Okay, so we can conclude. Oh, don't keep yourself unmute. Be muted, okay? Don't break it, please. I'm from Rajasthan, by the way. Somebody was asking, no, I'm from Rajasthan. I'm from Rajasthan, working from home. Okay, so remember one more thing. Away from the charge, the field gets weaker and density of the field lines is less. Remember, suppose you are having a charge like this plus Q. Suppose you're having a plus Q charge, and electric field lines are originating from this plus Q charge like this. Shaun, 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 shaun. Okay, so if we see the formula also, suppose if I need to find electric field at this point, so I will say it is KQ by somewhat R1 square. And if you need to find electric field at this point is very much greater than the initial point. Here the electric field will be KQ by R2 square. Okay? So as we proceed, electric field intensity decreases and decreases. Proceed matlab as we go far away from the charge, electric field intensity decreases and decreases. Okay? I hope students it's clear. I hope students it's clear. Okay, let us proceed next. Students, I'm launching a video. I've launched it. Suppose I place -1 coulomb charge here like this. So you can see the electric field vectors, how they're changing. If I bring one more -Q charge, you can see the electric field pattern. You can see the electric field lines pattern here. See, if I'm bringing -1 coulomb charge, see how the electric field line pattern is on the screen. Yes, we know this thing that for a negative charge, electric field lines are inside. If I keep one more minus charge near to it, you can see how the pattern is now. This is the variation. Suppose now if I'm bringing a positive charge, source charge, plus 1 nanocoulomb, nano matlab 10 minus 9 coulomb. So you can see how the electric field line passes from a positive charge. If I keep the negative charge on this, you can see the pattern. This we have drawn on the slides, no? Now previous slides. I hope you all know this thing. Recently only we have drawn this thing, that if a positive charge and negative charge are kept together, electric field lines, how they look. And you can see here in the experiment how the electric field lines look. I hope it's clear. And I can see in the experiment, today my neck is something, it's happening. I hope it's clear that electric field line originates or generates or comes up from this positive charge or and ends or terminates as what? The negative charge. I hope it's clear. Please reply in the chat box. Please, students, reply in the chat box. So now we'll understand. Now write a new heading, uniform electric field and non-uniform electric field. Write it fast, students. Write a new heading, uniform electric field and non-uniform electric field. Write, students, new heading, uniform electric field and non-uniform electric field. Trupti says same density of field lines, that is uniform. Okay. So now we'll see the definition first, theoretical definition first we'll see. So what does the theoretical definition says about the uniform electric field? This is important. No, first of all, theory experiments, and then we'll understand the physical significance and numericals. See, they say it is represented by, what they talk about this uniform electric field. They say it is represented by a set of parallel uniform spaced lines. How does it look? It's like this. So this is uniform electric field lines, and these are having a very sophisticated, symmetric, well precise, sophisticated, symmetric spacing between their neighboring lines. So wherever you see such kind of picture, you'll comment to the teacher, sir or ma'am, it is what? It is uniform electric field. It is what? It is uniform electric field. I hope it's clear. Non-uniform field, what does it mean? It means non-uniformly spaced lines and curved lines represent a non-uniform. Simple. Non-uniform तो कैसे भी हो सकता है. It can be anything like this, randomly, like some mad thing. So it's like this. But see, non-uniform can look very random, but here it is somewhat, kind of, we'll say somewhat sophistication is done here. Somewhat it's well spaced. So we can say like this, if you talk about the parallel electric field lines, they will be having not a proper spacing in between them. So if it is D1 spacing, D2 spacing, so if it's D3 spacing at the end here, if this is D3 spacing, we'll say D3, D2, D1. But here if I say D1, D2, D3, I will say D1 is equals to D2 equals to D3. So this is this difference between uniform electric field and non-uniform electric field. I hope it's clear to all of you. Oh, nobody told me to record to the cloud. I hope, students, it's clear to all of you. Yes, sir. Yes. Let us proceed next. So are you ready for the challenge? There is a question. So now I'll ask you a question which is based on, hold on 1 second. It's creating problem. So now I'll ask you a question which is based on uniform and non-uniform electric field. Now I'll ask you a question which is based on uniform and non-uniform electric field. Okay? I hope it's clear. Okay, I hope you're ready for the challenge. Answer this question, students, fast. I hope the question is properly visible to you, all of you on your screen. What does the question says? Consider the situation shown in the figure below. What are the signs of Q1 and Q2? If the lines are in proportion to the charge, what is the ratio of the Q1 and Q2? You have to find it, students. I've already told you, if the field lines are well compact, close to each other, we'll say electric field intensity is greater. If the field lines are far away, we'll say it is what? It is less in electric field intensity sense. So what is your answer? Any one of you please reply here in the chat box. What is your answer, students? Any one of you please reply in the chat box. Some are saying this, some are saying this. Okay. Okay, let us go through the solution. So this is the picture which is given to us. This is what? This was the picture. Some students are saying Tirupati, saying Abhishek, you sand, then we cut out. Okay. So this is Q1 charge. This is Q2. From the Q2 charge, if you see, electric field lines are originating like this. Okay. And we talk about the Q1 charge, electric field lines are terminating on Q1 charge like this. Okay. So remember always, whenever we have already studied this thing, let me remind you again. Whenever the electric field lines are originating from something, we can just directly, instantaneously, very fast, we can comment on the nature of the charge. That such charge is basically, Gen C is saying something else, other answer. That this charge is basically a positive charge. If electric field line is originating from some charge, this charge is known as positive charge. Okay. And if we talk about the Q1 value, here you can see electric field lines are terminating on Q1. The field lines are terminating on Q1 or ending on Q1. So we can comment from this just by looking at this, how when we see the picture like this scenario, electric field line is terminating on this charge. So we'll comment like this, we'll say like this, that the nature of this charge is negative. So Q2 is positive as per the theory, Q1 is negative. Okay. Next, they are saying us, let me erase all these things. Remember now one more 5-star concept. So I'm giving you here a 5-star concept. Remember it always. What does the concept says? It says like this: Q1 charge. Remember this, that the magnitude of the charge. Write this concept in your notebook fast, students. This is a 5-star concept. That the magnitude of charge is directly proportional to number of electric field lines. If you see Q2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So Q2, sorry, 18 it is actually. Because 12, 13, 14, 15, 16, 17, 18. Okay. So from Q2, we can see, we know this thing. Q2 ka nature is what? Q2 is positive charge because the electric field lines are originating from Q2 charge. Hai na? So I will say Q2 is positive, but its strength is equals to number of field lines are 18. So we'll say magnitude of Q2 is what? 18 only, 18 column. We can say like this. So the answer is this. By using this concept, very good. So we'll say magnitude of the charge is directly proportional number of field lines irrespective of the nature of the charge, whether negative or positive. How we can find out the nature of the charge, positive or negative? That if the field lines are originating from a charge, we can say the nature is positive. If the field lines are terminating on a charge, we can say the nature is what? Negative. If the field lines are originating from the charge, we can say the nature is positive, and the field lines are terminating on a charge, we can say the nature is negative. Okay. And thus magnitude will comment to this concept, that is magnitude of the charge is directly proportional to number of field lines. Remember all this. So now I will solve it fast. Just when you will divide both of this, you'll get this thing, that is Q1, 3Q1 is equals to Q2 per magnitude sense, because one of the charges is negative, no. So are you ready for the second challenge? Yes or no, students? Here is the second question in front of you on your screens. Class will go to 6:10. Class will be extended to 6:10. Then I will launch the poll. Those who want to be here, please be, at least be here. You know, NPS have to launch. No? Class will be at 6:10. Or at 6, just 4 more minutes. Just 4 more minutes, just for this question. Students, just for this question. I hope it's clear, just for this question. Are you ready for the challenge? Yes or no? Students, are you ready for the challenge? Are you ready for the challenge? Are you ready for the... Today we have just completed electric field lines, no? Are you ready for the challenge? Very good. Abhishek says yes. So answer this question. So why are some sources of charge, suppose some Q charge at some distance, this force के लिए भी कोई charge, इसके लिए भी कोई, जैसे एक single charge है जिससे field lines आ रही हैं, okay? Suppose there is some single charge via which these field lines are coming. So this structure of the field lines is given to you. They're asking from you, what is the relation between electric field intensity at A point? What is the relation between the electric field intensity at A point? What is the relation between electric field intensity at A and B point and C point? Okay. So here are your options. Please answer. I am giving you how many minutes? So it's 1 minute duration. I'm giving you 1 minute to solve this question. Jency from JNV Tumkur says option C. We'll see that is your answer, right or wrong. We'll see that C is right or wrong. So this is the last question of today's session, students. After this, I will take your doubts. Up to 6. After this, I'll launch the NPS and then take your doubts. Okay. Okay, I'm showing you the solutions. Just hold on. See, I've already told you. Wherever you find the electric field lines to be closer, electric field intensity at those points will be greater. But what I'm saying, I repeat it again. Wherever you will find electric field lines to be compact, electric field lines to be compact or closer at all those points, electric field intensity will be greater. And wherever you will find electric field lines to be random or far away from each other, you will say electric field intensity as less at those points. So we can comment like this: EA is equals to EC, okay, is greater than EB. I think C is the right answer. Yes, so I agree with all of the students. So as per this, the answer is this, that is C option. Okay. So let us fast, students, go through the summary of today's class and include all the points. Then I will launch the NPS and then I'll ask the doubts. Otherwise, you can leave the class. Abhi nahi, after the NPS. Don't leave now. So see, we see here, students. The first point is this, that electric field at a point is defined by the equation which is E equals to F by Q. What does it mean? Coulomb force per unit test charge will give you the electric field at a point due to a source charge. Electric field at a r distance to point charge, again same. We'll divide this equation, the first one. And we have seen also the resultant electric field at a point due to several charges. Okay. So we have crossed all the points. We have seen the electric. We have completed all the points. We have seen the electric field lines also. I hope you're able to see this properly. That what is electric field line? And we've seen few properties of the electric field line, that positive, from a positive charge, electric field line originate and terminate at what? And terminate at negative charge. Okay. So electric field lines originate from the positive charge and then terminate at negative charge. And as the field lines are closer, more is the electric field intensity. And the field lines are far away, electric field intensity is less. We have solved two numericals. Tomorrow we'll start with electric potential, students. I repeat to all of you students, tomorrow we'll start with electric field potential. Okay. Then we'll solve some numericals and then we'll see about the electric dipole also. Okay. So that was all about today's class, students. Now I'm launching the NPS for you. Hold on. Okay, students. So I'm launching here the poll. Please participate in this poll. NPS poll. So today I got an idea what are the things which you know. Tomorrow we'll start the electric potential, okay, or some numericals. Please participate in the poll, and if anybody is having any doubt, can ask. Please, students, participate in the poll. I am sharing the whiteboard with you, and if anybody is having any doubts, can ask now, okay. Participate in the NPS, and anybody is having any doubts, can ask. Participate in the NPS, students. And if anybody is having any doubts regarding the physics chapter, any of the chapters, please reply. If anybody is facing any doubt, can reply, students. Thank you so much for your participation. Okay, I really appreciate this. Any doubts? Anyone having any doubts? Any questions?